This tutorial will cover using a knowledge pattern inside a powercopy, encapsulating a knowledge pattern in a powercopy, and instantiating the knowledge pattern. My setup is the hopefully familiar standard truss that I've been using in previous examples and created in a previous tutorial, except that I've added a knowledge pattern that creates these diagonal members. Basically, I have created some wireframe geometry, a center line between 2 points intersecting this plane, between the axes of the truss and the top chord of the truss, and then based on that line I just hit, I created some parallel lines, basically offsets along this plane, and then I created the knowledge pattern that simply takes the length of one of these segments, this segment, and rounds it to the nearest integer, and then initiates a loop that, using a little bit of math, puts a series of points along that curve, shifting points back and forth, and creates datum lines between them. So segment equals creator modified datum. This is my call function that's creating the line. Okay. The reason why I went through these extra steps is so that if I edit inputs on this, go to generative shape design. If I edit inputs on the input geometry and swap out, say, 0.2 for this point, and run the knowledge pattern again, you can see the number of diagonals changes rather than just stretching out. It's actually, because it's measuring the length of this and dividing to take the nearest integer, it's changing the length, trying to keep the spacing the same among these diagonals. So I'll put this back. For the purposes of this, I'm going to, so I don't have to go through each knowledge pattern that I instantiate. I'm going to change it to automatic execution so I can just update. Now the first step is to drag the knowledge pattern inside the geometrical set. And this is similar to dragging parameters or functions into geometrical sets. It enables us to take the geometrical set itself and create a power copy of it. The only thing that will happen here that's a bit of a problem is that the knowledge pattern output geometry the links will be broken. So I'm going to delete it. And those links, because those links were broken because I dragged the knowledge pattern set, which is effectively a cut and paste. Now I have automatic execution on, so they're immediately recreated, which is great. And I'm ready to create a power copy. So I'm going to create a power copy of the entire segment. Maybe I will hide these extra points, again just cleaning things up visually, and even hide this plane. So I'm going to create a power copy. Go to Insert. I have to be in a generative shape design. Go to Insert, Knowledge Templates, Power Copy. And I'm going to call it Segment Power Copy. And on the inputs, I'm just going to change this name of 0.2 to reference point. Okay. And now I'm going to instantiate it. Instantiate. And I'm actually, before I instantiate it as a series of bays, I'm actually going to make another member going to this other chord. So I'm going to select main axis. Select the same reference point, and select the top chord where it asks for bottom chord, and the bottom chord where it asks for top chord. And there I have it. I have a diagonal going to the lower chord. And I'm going to change segment to, I've actually put this segment inside this segment, so I'm just going to call the first segment bay. And now I'm going to delete this power copy and create a new one of the whole bay. Knowledge templates, power copy, bay, power copy, inputs, reference point. Much the same procedure as before. And then I'm going to instantiate this power copy. Instantiate, I'm going to select main axis. I'm going to select a new reference point. I'm going to select bottom chord, top chord. I'm going to make sure it goes after bay. Click preview. And this looks like what I'm hoping for, so I'm going to press OK. I'm going to select repeat Okay, and then I'm going to just keep changing the reference point and instantiate it down the length of the chord. Again, I'm selecting the red text for reference point, which brings me to reference point in here. I could also be navigating through the Power Copy dialog box. And so there I have it. I have the entire length of the truss with these diagonal members, and I can change some of these inputs. Say change this to 50. Maybe it's a bit much. Say 55. Maybe 57 or 53. Exit, and it's automatically updating. I can, of course, make this smaller as well. Make the radius bigger, make the arc smaller. And the behavior is what I'd hope for and what I'd expect. Of course, this could have been done with UDFs. This could have been a more complex system. It could have been a series of different power copies doing different elements. This could have been combined with more real geometry dealing with end conditions and so on. But it's a very fast way to create to instantiate a number of power copies and really reuse create a number of knowledge patterns and really reuse a knowledge pattern in the same way you'd reuse any other geometry.